We are from Group21 and we will talk about our website, Student Data Management System. My name is Muhammad Daniel and I will start with my part. In order to simplify the administration of student records, the proposed project aims to develop a student data management system specifically designed for university staff. The main objective is to establish an organized system that enables efficient tracking of academic records, course enrollment, enrollment status, and student information. This approach will decrease human labor, reduce errors, and deliver real-time data access by digitizing these procedures. This system will set a high priority on usability, guaranteeing that employees and university staff can use the system with ease while preserving the confidentiality and accuracy of the data. A three-tier architecture will be used in the design of the website to ensure a responsive and user-friendly interface. The front end will utilize HTML, CSS, and JavaScript. PHP will be used for server-side features in the back end, taking advantage of its SQL database flexibility. MySQL will be used in the database creation to hold structured data, including user account, department information, academic records, and student information. Role-based access control, for instance, administrators and staff, dynamic data entry forms, and analytic dashboards serve as essential parts. Data tables will be used to construct relationships between classes, including departments, courses, and students, guaranteeing the data integrity and effective querying. We use a mix of open source frameworks and tools for development. XAMPP will be used in the local environment, combining PHP for scripting, MySQL for database administration, and Apache as the web server. For optimal performance, the system will be installed in production on MariaDB database server. JavaScript will be used for interactive front-end element, SQL for database operations, and PHP for back-end functionality. The presentation, application, and data layers makes up three-tier architecture of the data students website. For operations like maintaining profiles and viewing student information, the presentation layers uses HTML, CSS, and JavaScript to generate user form and tables. With script like users.php, handling user authentication and create, read, update, delete activities, the PHP build application layer manage session management, database connectivity, and server logic. To ensure data consistency, the data layer employs a MariaDB database with tables like users, student list, and academic history connected by foreign keys. Only administrator user are able to perform administrative duties um, such as create department or create user and delete user due to role-based access restriction to user staff. So a LAMP stack powers the system with PHP program being served by Apache, JavaScript very fast form inputs, while Bootstrap guarantee a responsive interface. Alright, so this is our demonstration for our website. So let's try to make admin page. Alright, so this is our home page. So for admin, they have a full access for department lists, course lists, and user lists. So the full access, what I meant was it can add new department and delete new department, and same as the course and user list. So let's try to make a new admin. as we can see here, admin2 that we created appears, and for our database it also appears here. So let's try to add department list. Let's try to FOE, oh sorry, maybe FEM, yeah. So the department that we created listed here, and also it listed here. So when it synchronizes, it will appear in course list 2 as we want to make a new course. So department, the FAM we just did, for example, English. So as we can see here, we can see the course that we did, English, and for the course list, yep, it appears here. So let's try to delete it, and the course has been deleted. So let's try that. Yeah, so after we deleted the English courses, it still appeared in the database, but we make it a new column, deleted flag. If it's 1, it means it's already deleted, so it's like a soft delete. So let's try to go to the stuff. So this is staff home page. So the staff, um, they can't create a new department or create new courses, but they can make a new student. So for example, let's try Daniel. So middle. So the student that we created is appeared. Let's try to see on the PHP admin. So this one, yeah, see, Daniel Don. Alright. So we also can add academic. So for example, this Daniel is on 3rd semester 2024. Course, let's try calculus, regular, and pending. So we can save it. So as we can see here, it will appear on his academic history and the beginning of semester status, end of the semester status, and the staff, they can edit the action. Yeah. So if we do the complete, it will change the complete. Yeah. Alright, so I think that's all. Thank you.
Hi, I'm Oswald, and I'll be talking about the task 3, which is the threat analysis risk assessment on our system. So for the threat analysis, we have the spoofing, which our system uses the MDH, the MD5 hashing and session validation. So the session validation will force login redirects and blocks unauthorized access. For the tampering part, our system uses the escape strings, which the code is located in the master.php and required form fields. And for the reputation, we have our database timestamps track changes, such as the date created in tables. And next, for the information disclosure, our system uses the HTTPS detection and role-based UI hiding. Uh, for denial of service, we have our system use lightweight and optimized queries with index tables. And for the elevation of privilege, we have UI-based role checks in the navigation.php, which hides the admin features to prevent unauthorized access by other users. So for the grad scoring, we put our spoofing at a risk of 6.0, which is a medium because the MD5 is big. The session validation reduces the risk. And for tampering, we put it 4.0. So the basic the basic escaping prevents a trivial SQL injection. And for the reputation, we put it a low score of 3.0 because the timestamps provide minimal accountability. And for the info disclosure, we put it at 5.0. And denial of service 3.0 and elevation of privilege 5.0.
Hi, my name is Farish and I will be talking about task 4. There are three main roles to consider in data management. Data user includes admin staff, admins, staff or developers who control or authorize data processing. Data processor, external parties like database or hosting providers who help process data. And data subject, which are the students using the system, and their personal data is what's being protected. Moving on, let's go through the data lifecycle stages and how the PDPA principles apply. Collection. Under Section 6 and 7, you must get the student's consent and give a privacy notice. And this is done during the registration. Which is done by admins and developers. Penalty being 100,000 ringgit or 2 years. Next, storage. As per Section 9, we secure databases using passwords, encryption, and firewalls. Handled by DBAs and developers. Penalty 300,000 ringgit for 2 years. Next, processing. Following sections 6 and 11, data is only used for specific purposes like tracking or registration and keep accurate. Done by admins and developers. Penalty for violating 300,000 ringgit or 2 years. Share or disclosure of data. Section 8 and 39 say no data should be shared externally unless there's consent or legal reasons. Only authorized staff can view it. Handled by admins. Penalty 500,000 ringgit for 3 years. Monolis retention or destruction of data. Sections 10 and 12 require us to delete all data after a set period and allow students to request updates. Managed by DBAs and admins, penalty being 300,000 ringgit for 2 years. By aligning each stage with PDPA principles, we ensure data is handled responsibly and avoid legal penalties. Thank you for listening. We limit database access to only authorized users. Different accounts are created for roles like admins and staff, each with specific permissions. For example, staff accounts only have select instead update to reduce risk of accidental or malicious action. Secondly, password hashing, where user passwords in the database are securely hashed. So, when if someone gains access to the database, the raw passwords remain protected. Next, we have SQL injection prevention, where all form inputs are validated and sanitized to prevent such attacks. This ensures attackers cannot insert malicious SQL code through interface. Next, we put up firewall and network security to block unauthorized external access. We close unnecessary ports like the default port of 3306 to ensure untrusted device can reach the server. Next, we have database privilege segregation. We apply the least privilege principle. For example, admins have full access including drop table, but staff can only read or write data. This reduces damage in case of a compromised account. Next, soft deletion. Instead of permanently deleting records, we use delete flag to mark them as deleted. This helps in preventing accidental data loss and makes recovery easier. Last but not least, we implement audit trail. We maintain an audit trail to track changes in student records. This helps detect unauthorized access, supports breach investigation, and holds users accountable. By applying these layered security measures, we strengthen our system against threats and align with good cybersecurity practices.